For number 30, we have to find the area of the triangle using calculus. So let us plot in the triangle. So we begin at the point 2, 0, so that is over here, 2, 0. And then we have the point 0, 2, so 0, 2. And then we have the point minus 1, 1. So that is minus 1, 1. And now we just have to join these points. So we do have this line over here in orange. We do have the green line. And then we have the yellow line. And we can see that the area of the triangle is the one that I'm shading here in yellow. So before we can find this area using calculus, we do need to find the equations that join these points. So let us begin with the orange line. The orange line joins the point minus 1, 1 with the point 0, 2. And because all of these are straight lines, they'll be equations of the form y is equal to mx plus b. And all we have to do is find m and b. So m is y2 minus y1 over x2 minus x1. So let's call this point here y2, and let's call this one y1. So when we plug it into the equation, we will have, let's see, 2 minus 1 over x2, that is 0, minus 1. So when we put this in, this is just 2 minus 1, it's just 1, over positive 1, so just 1, right? So our slope is 1, y is equal to x, and then we do have to find the y-intercept, but we can see here from this triangle that it does hit the point 0, 2. So this point over here is the y-intercept for this equation, so we don't even have to plug in the values. So we just know that this is y is equal to x plus 2. So let us write this down. Y is equal to x plus 2. So once we found the orange line, let us find the equation for the green line. So the equation for the green line, it joins the points, let's see, it joins the points 0, 2 with the point 2, 0, yeah, 2, 0. So we'll call this one over here y2 and this one over here y1. So when we plug it into the equation, this is y2 is just 0 minus y1 is 2 over, let's see, over x2, which is 2, minus 0. So this gives us minus 2 over 2, which gives us minus 1, right? So we do have y is equal to minus x. And once more, the y-intercept is positive 2 because it does touch the point 0, 2. So we don't have to calculate that. So this is just minus x plus 2. So once we have this, let's just write this here. Y is equal to minus x plus 2. And all that's missing for us now is to find the yellow line. So the yellow line connects the points, let's see, minus 1, 1, with the point 2, 0. So let's call this one our y2 and this one our y1. So when we plug it into the equation, we do have y2, so 0 minus y1 minus 1 over x2, 2 minus 1. So we will have here minus 1 over 2 minus 1, which is 3. So just minus 1 over 3. So we have y is equal to minus 1/3 x plus b. Now, the y, we don't really have the y-intercept here. We don't know what it is. So we do have to plug in a point to see what it is. So let's just plug in the point 2, 0 here in the equation. So because 0 is my value for y, I'll go 0 is equal to minus 1/3 times 2 plus b. So when we bring this value over to the left-hand side, we will have that b is equal to, let's see, to 2/3. Yes. So our equation has the form y is equal to minus 1/3 x, which is our slope, plus 2/3. So let us write this down. This is y is equal to minus 1/3 x plus 2/3. So once we have it, we are ready to integrate. However, there is a small detail because, let's see, there's a tiny detail here, and I'll put it in a different color. So at this line over here, you can see that from the left, the upper boundary is the orange curve, and the lower boundary is the yellow curve. And then on the right, the upper boundary is the green curve, and the lower boundary is the yellow curve. So we do have to break down this integral into two parts so that we can use the upper curve minus the lower curve. So the first integral, it goes from the point -1 over here. It goes from the point -1 all the way to the y-axis, which is just 0. And then we do the upper curve, which is the one in orange. So we have x plus 2, and then minus the lower curve, which is the one in green. So the one in yellow. Minus 1/3 x plus 2/3, and then all of this times dx. And then the second integral, it goes from 0 all the way to this point over here, which is 2. 0 to 2, and then now our upper curve is the green one. So we have minus x plus 2, and then once more, minus our lower curve, which is the one in yellow. So minus 1/3 x plus 2/3 dx. So let's just simplify this a little bit before we integrate it. So on the left-hand side, it goes from -1 to 0. This is x minus 1/3 x, so that is x plus 1/3 x, which is 4/3x, right? And then we have 2 minus, this minus gets multiplied, minus 2/3. So that is also plus 4/3, and then times dx. Now for the second curve, it goes from 0 to 2. So we have here minus x, minus 1/3, so we have minus x plus 1/3, so that is minus 2/3x, and then we have 2 minus 2/3, which is plus 4/3, and all this times dx. So once we have it, all we have to do now is integrate and then apply the boundaries. So this is on the left integral, this is 4/3 times x squared over 2 plus 4/3x from -1 to 0, and then plus minus 2/3x squared over 2 plus 4/3x from 0 to 2. So all that's left for us to do is to calculate our boundary. So the upper boundary here on the left integral, when we plug in 0 for x, all these terms are going to disappear. So we don't care about this. And then let us do the lower boundary. So this is minus 4/3 divided by 2. This is 4/6 minus 1 squared. And then minus 4/3, right? Because it's 4/3 times -1. And then we have plus, let's apply here the upper boundary. 2. So that is minus 2/3 times 2 squared. So 4/2. Oops, I wrote 3, but I meant 2. 4/2, right? No. And then plus 4 times 2 plus 8/3. And then when I would do the lower boundaries, it would just be 0 everywhere, so it would just disappear. And now let us just compute this. So this is, let's see, this is minus this plus 1, right? So minus 2/3, which is minus 4/6, and then minus minus, so plus 4/3, and then on the right-hand side, we have, let's see, the 2 and the 2 cancels out, so minus 4/3, minus 4/3, and then we have just plus 8/3. So these two, they cancel out, so we have minus 2/3 plus 8/3, which is, this is equal to 6/3, which is equal to 2. So 2 is the area of our triangle defined by these points. And just to recap what we did, we just plugged in the points, right? And then we found the equations that join these points, which are linear equations. And then we set up our integral by dividing it into 2 parts so that we could consistently have an upper boundary and a lower boundary.